All right, so although we have three events here that are not mutually exclusive, actually, let me read the question here, back here. Melissa has been keeping a record of probabilities of events involving her violin string breaking during orchestra rehearsal. We'll call that event B. A pop quiz in math, event Q. Her team losing in gym class, event L. We want, although these three events are not mutually exclusive, they can be broken into 8 mutually exclusive events. So we're going to figure out, we're going to answer some questions that are in your notes about this particular Venn diagram. Let's get started. So let's answer the first question here. What's the meaning of the region labeled 0.01? What would the meaning of that one be? Anybody at the green table? What's the meaning of that 0.01 in the middle? So that would be the probability, you can put this in your notes, the probability of the string breaking. We'll just put break. And it's the intersection, right? So this is and. The probability of the quiz. And the probability of the team losing. So all those three things happen to Melissa. It's not a very good day. Right? So you can put that part in your notes. And then I just put the words and under there to help you remember that that's intersection. Intersection means and. It's where they overlap. All three overlap. Okay. Everybody good? All right, let's look at the next one. All right, what's the meaning of the 0.03 there? Anybody at the orange table? Yep. So this is the overlap between those two. So that would be the probability that the string breaks and the team loses. Okay, everyone got that one in their notes? Okay, change. All right, so now we want what's the probability of either a pop quiz or Melissa's team losing today? So to find that, so the probability of quiz or, oops, not and, or lose. Or lose, right, so it means or, is equal to the probability of quiz plus the probability of lose, and then minus the probability of quiz and lose. I'm running out of space. Quiz and lose. I think we can write it over there. All right, so you got to find all of those things when we're finding the probability for an or. All right, so if the addition rule says that if they're not mutually exclusive, we have to find the probability of each one and then subtract the probability of the overlap. So now what are we going to add in here to find that probability? Anyone at the yellow table? So how about the probability of quiz? What things make up the probability of quiz? 0.09. What else? Huh? No, you're not finished with quiz. 0.04. 0.02. 0.01. There we go. Now, how about the probability of lose? Yep. Actually, I'm going to do this too for everybody. So there's lose, and here's quiz. Okay. 0.20. 0.03. 0.4. and 0.01. All right, so all of those things are in the lose category. And then we have to subtract, parentheses around this one, all of the things that are in the intersection. So what would be in the intersection? Mm-hmm. Yep, 0.04 and 0.0. Not 0.03, right? Because that's the wrong intersection. It's just the intersection of these two, the green and the red. So just the 0.04 and the 0.01. Okay. All right, so does everyone see how if we're figuring out the probability, we take all the probabilities for the plop quiz, we take all the probabilities for the team losing, and then we subtract the probabilities of the intersection. So this is where these two intersect, is the 0.01 and the 0.04. The lose and the break intersects at 0.01 and 0.03. And then all three of them intersect just at 0.01. And then break and quiz intersect at 0.02 and 0.01. Right? So all these things have different meanings. So the 0.04, for instance, here means the string breaks, but not pop quiz and not team losing. This is pop quiz, but not string break and not team losing. And this is team losing, but not string break and not pop losing. So, or pop quizzing. You can also write this like this. So this is this 0.02 here. I'll put it in green. I'll match the circle, and I'll make this one blue, just to kind of make this clear. All right, so this one here, that 0.02 here means the probability of lose and and it's, no, it would be and, I'm sorry, and not. So probability of lose and not break. One way you can write not break is, sometimes they put in oops, forgot the word P in there. You put a little line over it. That means not. There's a couple different ways to write not, and I'll show you all of them. We'll add them to our notes. But this would be probability of not break and probability of not quiz. And so this means not. All right, so that's what this 0.2 means. The 0.09 is quiz but not break and lose. Is everyone clear on each of the parts of this? All right, so let's add this up. So we have 0.09 plus 0.04 because plus 0.02 plus 0.01 is going to be 0.13, 0.15, 0.16. So 16% of the time she has a pop quiz. And then we'll add in the lose. So that's the 0.2, 0.03, 0.04, 0.1. So 0.23, 2728. She loses a lot. And then we'll subtract 0.05. So you should have this one in your notes. All right, so that's going to be 0.44 minus 0.05. So that's going to be 0.39. Oops, there goes my pen. .39. Has everyone got this one in your notes? By the way, we didn't do a note check with the last test. I'm going to do a note check at the end when we finish up the last set of notes. Anytime after that to the final, you can have your note checked. We're just going to do one note check. I'll check it at once. Pretty good. Okay. Let's go on. All right, so we want to find the probability of a pretty good day, which means the probability of not break.
No popcorn.
And so and would be this one. And oops, probability of not quiz. Actually, I'll put one parentheses. I don't have to do so many. So many P's. Probability of not break. And oops, not quiz. And not losing. So what would that one be? We don't have an orange 4, right? No orange 4. On mine, what would that one be? So the probability of not breaking your string, not having a quiz, and not losing. So I think that might be. Not sure? Okay. Yeah?
0.57.
Yes, this one out here.
The one that's not in the diagram.
The one that it's not with the break and the quiz and the lose. So 0.57. That's the one.
One in the Venn diagram.
Yeah, so, yeah, if you,
It's gonna have it.
exactly. So if you want not all of them, you want the outside.
Mhm.
Anything else will include part of it. Okay, everyone got that one in your notes? And I think that was the last one. So a little review here. All right, so just a reminder with our Venn diagrams and the addition rule or. So if you have the probability, this means or, right? So the probability of A or B is the union, right? And we're going to add A, add B, and subtract the intersection. If they're mutually exclusive, I mean they can't both happen at the same time, then there'd be nothing in the intersection. And we have a couple symbols here. So this line here also means A, the intersection of A and not B. So this means this is only A. This is where A occurs but not B. This is where B occurs but not A. And this is where both of those occur. This is the intersection. This is A and B. Right? So we subtract that off because we've counted it twice. Because this intersection here is part of A and it's part of B. And we have a new symbol here. So underneath this one here, let's write this another way. So instead of not, you might see this. You might see probability of not B and not Q and not lose. So that's another way to write not. These mean the same thing. So, all right, so this means the same. So those mean the same thing. So add that one to your notes. Underneath this one, just put the not symbol, so that if you see the symbol, there's going to be one more, so you might want to wait. So if you see that symbol, you'll know what it means. So that means the same thing. So I don't want you to go like, why does there a B have a line over it? What do they mean? Right? So that just means not B. You might think it means B. It means the opposite, not B. Okay, so just put that one in your notes under this one. Right, and then let's look at this one, a little review here. So working out probabilities from a Venn diagram. Probability of A represents that the item is in A. The probability of, this is another way to say not. So not A is the item is not in A. So that would include all of B that's not in the intersection there, and the one that's outside. The probability of not A is the same as the probability of all minus the probability of A. Because together, A plus not A equals everything. The probability of A, this is A and B, has to be in both. So that's these two. Probability of A or B is everybody in A, the intersection, and so everyone in just A, everyone in just B, and the intersection. Right? So for instance here, if we had a number at random and we want to know the probability of A, there's 9 numbers here, and 1, 2, 3, 4, 5 of them are in A, so it would be 5 nines. If we want the probability of not A, right, so that's going to be the 4 that are not in A. 1, 2, 3, 4 nines, or you could take 1 minus 5 nines and you get 4 nines. And then the probability of A and B is the intersection. There's 2 in the intersection, so that would be 2/9. So let's add one more way to write not. So this is the last way to write, this is one more way to write not. The last one I'm going to go over. So probability of not B and not Q and not L. All right, so here are all of them have the same meaning. So just in case you see them written different ways, you'll know what it means. Okay. Now you can do please. That was the last one. We'll do now one more question together. I'll put up the closing. I'll give you a few minutes on that. I can put up all 3 closings, and then we're going to start multiplication rules. I'll give you the first page of the notes. I'll give you the second page on Monday. Depending on how far we get will determine how much of a Nearpod you have. Because we're making pretty good progress. We did that. We did that. This is the last one. All right, so here we have 50 students total. All right, and should have you guys stay for this class. I am record. So I see me with the microphone. I am recording it for all of you. So watch the recording tonight. I'll label it, and then there's a Nearpod. So you'll watch today's recording. That won't be a Nearpod. It's just the recording, and then do the Nearpod that goes after that. Okay. That way you didn't miss any of the instruction. And then I have a new set of notes for you. So you may as well. So I have the first page of the multiplication rule. So go ahead and take one of those. I'll give you the second page on Monday. You'll need that. If there's anyone else you see, you can grab it for them too. All right, so we have 50 students total. 16 students take chorus only. 2 take both band and chorus. 24 students take band only. And then 8 students, they don't take anything. All right, so let's see if we can find the probabilities of these things. How about the probability of band and chorus? Green 3. So what would be the probability of band and chorus?
2.
Adam?
50.
50, yeah. And that would reduce to 1 out of 25. How about the probability of band? Anybody at the blue table? No. You are correct. 26 out of 50. Because we've got to include those 2 over here. They take band too. And that would reduce to 13 over 25, so more than half. All right, how about the probability of band only? Purple 3.
24 out of 50.
Yeah, 24. My 50 here looks like a 56. 20, oops, and I wrote 25 when I meant to write 24. So 24 at 50, which would reduce to 12 25ths. And then probability of choir only, no yellow 3, red 5. So what's the probability of choir only? Yep. So that would reduce to 8 out of 25. So now we want the probability of chorus or band. So that union symbol means or. So that would be the probability of choir plus the probability of band and then minus the probability of, oops, there it goes, probability of choir and band. Oops, running out of space. Let's move it over a little bit. Oops, can't move my and symbol. Come on, come on, there we go. My little plus sign didn't want to move. There we go. Now we got everybody in there. All right. So do we have an orange? Nope. 2, nope. Purple 4. All right. So probability of choir.
Isn't that like 16?
No.
Or no. 18.
Yep.
Is it all?
Yep. D.
Yeah, I really
And then plus the probability of band.
plus 26.
Yep.
Or
Yep.
bless you.
Thank you. And then we have to subtract the probability of band and choir. So what would we subtract?
Which is minus 2 over 50.
All right, so that's going to give us 18 plus 26 will be 44. Right, and then minus 2 would be 42. So this is going to be equal to 42 over 50, which we could reduce to 21 out of 25. Oops. Oops. Got an extra line in there. Took so long to come up. I wrote the line twice. Now, interestingly, we could also do this. So this here is also equal to 1 minus the complement. So that would be 1 minus the probability of no band. I'll do this symbol, this one, and no choir. Or excuse me, or no choir. So probability of band, not band, or not choir, which would be, there was 8 of them. So that would be 1 minus 8 out of 50 is also would give you 42 out of 50. So these two are the exact same answers. So the probability of band or choir is equal to 1 minus the probability of not band or choir. So just kind of bring those together. Okay. Any questions on these? All right, that's going to end this part of the lesson. So I'm going to stop.